Good, we're on. Well, first of all, I guess thank you everyone for staying on so late. My name is Yan, and I'm currently working for a games company called Space Ape Games, but I'll be transitioning to a new company called The Zone in Hammersmith, where we are building, I guess we want to be the Netflix of sports streaming. So, and we are going to be hiring Node.js developers pretty soon, so do come to me afterwards if you are interested. Also, my friend Scott here as well.
Yeah, hi, I'm Scott. I'm currently consulting at a company called LifeWorks. They're also hiring. They're trying to become the total wellbeing solution for employees in the HR space. So, yeah, have a look at the site if you're interested.
So me and Scott worked together for a company called Yabble, where we were trying to build a social network that's a mix of Instagram, Twitter, and Facebook before. And when I got to Yabble, this is pretty much what we had at the time, monolithic system setup, where you got a couple of EC2 instances running. And being an early stage social network, we didn't have that much traffic, but we did manage to grab a few, I guess, semi-famous Instagram or YouTubers onto the platform. Emily, for example, was one of our biggest users. She had about 50,000 followers at one point, and like many other people on our platform, she would run campaigns where she would create posts and say, hey guys, come and vote on my post, and then at exactly 10 o'clock, I'm going to announce a lucky winner for this beautiful designer handbag. And you can imagine what happens at 10 o'clock, right? So baseline traffic is very low because, again, not that many people using it, but all of a sudden, 10 o'clock, boom, you get this massive spike of sometimes 100 times your normal traffic, which is terrible when you're an engineer to have to look after a system like this, because it's really hard to provision a system whereby you get these massive spikes all the way through the day. To make things worse, because we have all these random spikes that we can't predict, so we have to run our cluster at a much lower utilization level than we like, and because EC2 scaling takes such a long time, which means we also have to scale up a lot earlier as well. And you put the two together, it means that we're spending a lot of money for resources that we're not using. By my estimate, we were probably getting about 5% of our money's worth. And at the time, deployment takes about 30 minutes and requires downtime. So this is literally the whole system goes down and not available with no error messages. Anyone goes to the app, would just see a buffer screen for 30 minutes. And then notification comes back up, which is clearly not good enough these days. So we sat down together as a team and we decided what do we want from our architecture. And we decided that we want deployments to be small, to be fast, to have no downtime. And we don't want to be in a situation where we have to do lockstep deployments with the client team because of the sheer amount of coordination and stress involved. We also want individual features to be deployable individually, and they should be loosely coupled through messaging as well. And from the infrastructure point of view, we want to cut down the fat that we have in our AWS build, which there were plenty. And we also want to minimize the amount of effort that we have to spend babysitting the infrastructure. As far as I'm concerned, the infrastructure should work for me, not the other way around. I'm an engineer, I'm not a professional babysitter for Amazon EC2 instances, which is ridiculous. Right? We also inherited a lot of technical mess, and that is a very conscious choice of wording. You hear people talk about technical debt all the time, but really, for something to qualify as a technical debt, it implies that someone at some point have to make a conscious design decision to take some trade-off so that you gain velocity in the short term, but with a plan to pay it back. That's how that works. You have to have a plan to pay it back somehow. What we had wasn't that. So whilst we're trying to address all this problem that we have, we don't want to take 6 months out and just do nothing. And in fact, we want to deliver things to our users faster than we've ever done. And if you fast forward just a few months, we end up with an architecture that is both event-driven as well as service-oriented. And at that point, we had about 170 Lambda functions running in production, and we were paying for Lambda about 5% what we were paying for EC2 for comparable amount of compute resources. But more importantly for me is how much velocity we were able to gain without having to hire a massive team to go faster. We went faster by allowing the people that are there to be more productive and to deliver things faster. So going from doing a deployment maybe 4 to 6 times a month, because again, 30 minutes downtime every single time, so who want to do that often, right? To be able to do the things, I think deployment about 80, 100 times a month, with pretty much the same size team. So that's a massive gain in terms of velocity. For the moment, we decided that Lambda is a good fit for the direction that we want to move towards. To having that first Lambda function actually running in production, we had to answer a whole bunch of questions to make sure that we can actually operate this architecture in production responsibly. That means we need to understand how we're going to do continuous delivery, what about testing, and how you're going to do logging, monitoring, alerting, and so on. How you're going to do things around distributed tracing to solve those more complex problems that you have when you have a microservices. And what about config management and security? And before we talk about all that, I think Scott is going to spend a few moments and tell you about some of the work that we are able to do.
Yeah, sure. I'm just going to give a couple of very quick examples of how we were able to leverage these serverless technologies to evolve the platform and deliver value quite quickly. Unsurprisingly, it was a social networking app. It had a search capability. You obviously want to be able to find all the people on the platform. You could search by first name, last name, username, that kind of thing. This feature already existed when we came along, but when we actually peeled away the covers, what it was actually doing was just a giant regex query against MongoDB. So it didn't really do anything for us other than some very rudimentary ranking of the users. And it ran into performance problems at around the 100,000 user mark, which, you know, for a social network with aspirations of reaching out to tens of millions of people was never going to be good enough. We were able to fix it though quite quickly. We started off at the legacy monolithic application. And we got it to emit some events that were pertinent to search. So if a user created an account, we'd publish an event. If they changed their name or something like that, we'd publish an event. And these were going onto an Amazon Kinesis stream. Kinesis is one of the event sources for Lambda. So a Lambda would pick up batches of these events, process them, and update an index in Cloud Search, which is a hosted version of Solar. We could then very simply just stick an API on top of this, use an API gateway in Lambda. API gateway kind of does what it says on the tin. You can map RESTful endpoints to Lambda functions that get invoked when you call that URL. And that was simply just querying the index in Cloud Search to return the results. This meant that pretty quickly it was performing at the levels we needed it to, and we could also change it more easily as well. An example of where we started to gain a bit more confidence using Lambda and also running it in production was when we had to rebuild the feed. As with most social networking apps, the feed was kind of the epicenter of it really. It's a bit like your news feed in Facebook or your timeline in Twitter. Unfortunately with our feed, it didn't actually do anything we wanted it to. The product guys were really good actually, and they've written a very detailed spec of what they wanted it to do, but when the QAs created a test plan based on this spec, all of the tests failed. It just didn't work basically. From our perspective as well, when we looked at the code, it was just a big ball of mud. So actually trying to figure out what it was doing was a bit of a nightmare as well. And this was exacerbated even more because this happened. When we came along, there'd been a massive change of the guard. I think the new CTO had fired about 16 people. So we couldn't even ask the people who had done the work, you know, why he was doing what he was doing. So it was difficult. The only option really was to go back to the drawing board, sit with the product guys and look at this spec. And again, we started at the monolithic application and we got it publishing some events that we cared about for this stuff. So we wanted to know when someone posted a YOBL, you know, when they starred one, unstarred one, that kind of thing. If we take the example of them posting a new YOBL, that was then going onto a Kinesis stream again. We had a Lambda for distributing YOBLs to the people that follow you. That could be potentially quite an expensive operation to figure out who was following you. You know, for someone like me with no mates, it's quite cheap. For someone with, like Emily, even at this early stage, I think she must have had 50,000 followers or something like that. So that was an operation we didn't want to be doing over and over again. So we did it, and then we broke the followers into batches and published a message to an SNS topic with the batches of followers. We then had a downstream Lambda that was actually responsible for going through those followers and adding the YOBL that had been posted to each of their feeds. By having this, we kind of get some inherent retry logic around the SNS part away from the expensive operation. If you have an asynchronous Lambda that's been invoked by something like an SNS event and the invocation fails, it will actually automatically retry 2 times for you. You can also very easily configure a dead letter queue if you want that the message can eventually land on. So the feeds themselves were actually just sorted sets stored in Redis, and we then stuck an API on top of this so that the phone could just say, get me my news feed, and it would pull it out of Redis. Another thing we were trying to do when we did this stuff was make sure that the customers got the value as quickly as possible, so we didn't want to wait for the app teams to catch up and start calling our APIs, and we also didn't want to punish people with old versions of the app, so we would typically proxy the existing legacy endpoint to our new endpoint so that straight away people were getting these new feeds that this time actually worked, which was nice. So yeah, I'm just going to talk a bit about how we actually got this stuff production ready.
Thank you, Scott. So I guess the number one advice I would give in terms of getting production ready with Lambda is that don't try to write your own framework. There's a new one every single week anyway, as it is. Just find one that's try and test it as battle-hardened, and the most popular framework right now is the serverless framework, and if you're using node.js, it's kind of the go-to framework nowadays anyway, because it's also written in Node. There's of course Amazon's SAM framework as well. It's worth checking out. And once you start writing a Lambda function, you're going to have to figure out how you're going to test it. And as far as testing is concerned, this is my favorite book. It's pretty old now, I guess it's almost 20 years old, but it's still a pretty good book. It's probably the first book I've seen that talks about what we know as the testing pyramid nowadays, where you've got unit tests, and if you've got a bit of a logic, the business logic that's encapsulated into a module or an object, you can still write unit tests around them the same way that you've done before. And where you got the integration test, where you want to test your code against code that you can't change. And ultimately, a Lambda function is just a bit of code that Amazon is calling on your behalf when some event happens. So there's nothing that stops you from invoking the same code to exercise its business logic by calling it with a stopped context event, context and invocation event. What's important here to remember is that because the purpose of this test is to test your code against things that you don't control, so for us it's important to wire the test so that it was talking to the real DynamoDB tables or real downstream systems that we depend on. And then once your function has been deployed, you want to run end-to-end testing, which are your acceptance tests. And as you go up and down this triangle of this pyramid of testing, unit tests is going to give you much faster feedback loop, but you get much better, much stronger confidence what you're doing is actually going to work with acceptance tests where you're testing things end to end. Another thing, another key message I took away from reading this book, and I'll read, I guess it's quite long, that we find tests that mock external libraries often need to be complex to get the code into the right state for the functionality that we need to exercise. The mess in this test is telling us that the design is not right, but instead of fixing the problem by improving the code, we have to carry the extra complexity in both the test and the code. And the second risk is that we have to be sure that the behavior that we stop or mock actually matches what the external library would do. And even if we get it right once, we have to make sure that those tests are remain valid as we upgrade those libraries. And I think the same principles apply in this increasingly service-oriented world that we live in, that we depend on so many different services that we can't control, and we shouldn't try to mock those services. And ultimately, I think serverless has got a very different risk profile to its previous paradigms. And if you focus your testing effort on what goes on inside the function, you're going to miss out on a lot of things that can actually go wrong when your code runs the first time. For me, personally, the first thing that goes wrong when I create a new function is I forgot to give it the right permissions. I run a new Lambda function that talks to DynamoDB table, but forgot to give it the permission to talk to the table. So the first time I deploy and run it, bam, IAM permissions error. So I fixed that, great. Now let's run it again. Second error, resource not found because I forgot to create a table. It's not part of my deployment pipeline. So all of these things you're not gonna find out when your mock and your sub is telling you everything is fine. And this problem with creation, or I guess this risk of configuration and resource provisioning just gets worse the more you have, the more functions you have, because for every single one of the Lambda functions and resources you're using, you have to consider, do you have the right permissions? Have you got the resource creation included as part of your deployment pipeline? Furthermore, it's my observation that with Lambda, a lot of complexity that we normally face with traditional software development has now gone away. Gone away with the management of concurrency is now all done by the platform, and a lot of frameworks, caveats, we don't have to deal with web frameworks anymore. So your code is actually much simpler. The risk of you shipping something broken has now largely shifted to how your code interacts with other services that's external to your code. And since the whole purpose, for me at least, of writing any code at all is so that we actually ship something working at the end of it. And for me, that's the goal that we should optimize towards in terms of how we organize the way we work as software engineers. And even if that means we have to give up some of the feedback loop that we love so much, but for me, if your feedback loop is feeding you false positives, it's not going to help you learn the right thing in order to deliver working software faster. Another thing that this wonderful book talks about is how, wherever possible, an acceptance test should exercise the system end-to-end without calling into its internal code. An end-to-end test interacts with the system only from the outside through its interfaces. So in the search API example that Scott talked about earlier, to test this system, we will talk to the legacy system via HTTP, the same way that our client apps would do. And then we'll verify that after all this background processing happens, we're able to search the newly created user by first name, last name, and username within an acceptable time limit. So now you're writing your exercising your integration test by running your code locally and talking to the real downstream systems. And once it's deployed, you're still talking to the same code, but in this case, you're talking to it through API gateway. So the only difference in how these two types of tests exercise the code is in how the function is invoked. So what we do is that we can write the same test case and apply them to both integration and acceptance tests by defining the when steps with a simple toggle that depends on some environment variable. If it says handler, then it's going to invoke the function code locally with a stuffed context and event object. Otherwise, it's going to talk to the real API that's been deployed. And in terms of once you've got your automated test figured out, you now have to figure out how you're going to deploy your code automatically. And this is one of the things that really annoys me when you got all these magic scripts that are only there on the Jenkins, and at some point someone, maybe Scott, will break the build, and then I have to go figure out when he's hungover and what else going on. Why did he break it? It didn't actually happen, but it makes it a great story. Because there's no source control, there's nothing to tell you, when did he change it, what did he change, why, and more importantly, what was there before, so I can quickly roll back. So for that reason, we have a very simple rule in the team that every single project will have a very simple build script that basically gives us a very simple DSL for triggering unit tests before we run anything, and then trigger integration tests, do the deployment, and then run the acceptance test after. And it's just a thin layer on top of what NPM and the Serverless framework gives you already. Again, I'm a terrible person when it comes to writing bash scripts, so everything is very simple, so it's actually turned out to be a good thing. And the important thing to notice here is that we are actually installing the Serverless framework as the dev dependency in the project. And the reason why we did that was, because we learned a very hard lesson when the Serverless framework decided to do a massive breaking change when it went from version 0.5 to 1.0. So in this case, when you are coupling your deployment mechanism to the version of Serverless framework that the project was created with, then you mitigate all the version compatibility issues you run into later when there's breaking changes introduced to the framework. And again, since everything is just a very simple bash script, that means you can reproduce the same build steps on your local machine as the same way that you will run on the CI box, which makes it very useful when it comes to debugging problems in the pipeline. In terms of continuous delivery versus continuous deployment, we were doing continuous delivery where every time we're using Git flow as well. So every time something gets merged to master, it means it's ready to go, it's passed the pull request reviews and so on. So at that point, we will run the unit test, integration test, deploy that to a dev environment, run acceptance test against that, and then you promote the same build to the next environment until just before production, where it's a single button click for someone to come in and do that. And the reason why we do that is because we needed a bit more, the QA teams need a bit more confidence around timing and control of that, and also because we don't deploy on Fridays, because we also have Friday drinks as well, which doesn't help when the things go wrong and everyone's hungover in the pub. So Scott's going to talk to you about logging.
Lambda actually gives you a few nice freebies when it comes to logging. And anything that you write to the standard output will get picked up on the Lambda service and asynchronously sent to CloudWatch logs, which is pretty cool. It does that asynchronously, so there's no latency added to your function invocation. It'll also enrich your log messages to some extent. You get a timestamp and stuff, and if it's been through API gateway, you're going to get a request ID, which is pretty nice. One thing it definitely doesn't help you with is searching these logs, because every time you create a Lambda function, it will create a new log group, and these things are scattered everywhere. You can imagine when we've got hundreds of them, they're absolutely all over the shop. You can mitigate this though. It's possible to go into the console, for example, and say, okay, let's stream my logs to Amazon's hosted version of the Elasticsearch service. But I think it's quite common in most companies that you've probably got some kind of centralized logging thing already in place. So you may instead decide to stream it to a Lambda function, and then you could do something like this. Say you've got the Elk stack, which is probably the de facto thing for log centralization. You could subscribe to these log trails and ship them off to Logstash. One thing to be aware of is that you don't want some dodgy manual process where whenever you create a new Lambda and therefore get a new log group, you have to somehow add this, to the thing that ships the logs. So what you can do, you can enable CloudTrail, and that allows you to listen out for actual system events. So the one we've got here is an event that gets published when log groups get created. And at that point, we can say, okay, we'll send this log group off as well to the function that ships our logs. It's also worth mentioning you can do the same sort of thing for log retention. By default, when a log group gets created, it's set to never expire, which I'm sure any of you messing about with GDPR and stuff know that's not going to wash. So when a log group gets created, you can maybe set it to 30-day retention or something like that. So at this point, maybe we've got all our logs in Elk, and we can use Kibana to search through them, which is pretty useful, but it's not the complete picture. The feature we were looking at before about posting a YUBL, from a user perspective, that's very simple. You just post a YUBL, but there's actually quite a lot of moving parts here. We've got HTTP, we've got Kinesis, we've got SNS, we've got different Lambda functions, which is all well and good, but then when you come along and say, well, my followers didn't get that post, then good luck trying to find where that happened. Even if you can search through the logs, that's not going to be enough necessarily. This isn't a problem that's unique to serverless at all. This is a problem that I'm sure any of you who are dealing with microservices have found as your applications become more distributed. You need a way of actually seeing how a message flows through the system. And correlation IDs are the typical pattern for that. So we can have an ID that's used from the first incoming request and flows through our system, so that we can log it and then get a chronological list of log entries to show us what actually happened as the message passed through. In terms of what we were doing at YUBL, the way we were doing this was to wrap stuff, so you can wrap your HTTP client or the AWS SDK clients as well, so that they actually capture the correlation IDs, and you can then log them as the message passes through the various components. So if it's HTTP, your wrapped client may stick the correlation ID in the request header. For SNS, you have message attributes, which is a nice place to stick metadata like this. For Kinesis, there's not really an equivalent place. You're probably going to have to bundle it in with the payload of your event, but it's well worth doing so that you get this traceability. Another thing worth quickly mentioning is that when it comes to distributed tracing, it's not all about finding issues. It could be functional issues, it could be performance issues as well, as we were hearing about in the first talk, for example. And one nice thing Amazon now give you is something called X-Ray, which is compatible with Lambda. So that will give you a breakdown of what actually happened in terms of timings. So the thing at the top, the bar at the top is the total invocation time, and then the one below that to the right is how long the code took to run. The one below that is how long the containers and VMs or whatever Lambda's using took to spin up. And then you get a breakdown of everything it was doing within that function, so you're going to see how long the download DB calls took or outgoing HTTP calls. And hopefully that will give you a better chance of actually finding if something's timing out or taking too long. It also gives you this nice little graph of the services that you're using and how they're linked. One thing that it doesn't quite do yet is if, for example, in your Lambda function you're making another downstream call to API gateway, you're not going to be able to drill down into what that was doing in the next way. It's just going to show up as this was a HTTP request that took n milliseconds. But hopefully that's something that AWS are going to look into. So Yang's going to talk a bit about how we monitored stuff and alerted on it.
So one of the interesting things that happens with Lambda is that you now lose access to the underlying infrastructure that runs your code. So for a very long time, we were used to running those monitoring agents and daemons that collects metrics and logs and ship them off asynchronously outside of their critical path. So now we lose the ability to do that. So we are more dependent on the information that we get from CloudWatch, which does give you a bunch of basic telemetries around your functions. And then you also find vendors like IOPipe, which gives you an SDK so that you can collect the metrics and then send them to your own system. The problem with the approach that IOPipe is taken is that with Lambda, there's no background processing, and everything you're doing has to be done as part of your function invocation. So that includes talking to IOPipe's own backend systems. And when you're talking about API gateway and synchronous resources, event sources like that, API gateway doesn't respond until your function finishes executing, which means your customer is waiting for your function to send its metrics and anything they're doing in the background. One of the workarounds you have in this place is actually piggyback off one of the things that you do get as far as background processing is concerned, which is Amazon collects the logs for you asynchronously. So if you write your custom metrics as a specially formatted log message, then you can actually have Lambda function that's shipping your logs to somewhere else to then identify those and then send them as the metrics instead. This is a very popular pattern amongst the new, new breed of tools that are designed with serverless in mind. Once you've got all your metrics, make sure that you set up dashboards and alarm and hook it up with Ops Genie and so on. And finally, with config management, the important thing to consider is that where you have a sensitive data like credentials or API keys, make sure that those are encrypted both at rest and in flight, and that you have role-based access to those credentials, to those sensitive data. Unfortunately, with SSM parameter store, you kind of get both out of the box. And what we do is when you got some secret that you can store in the SSM parameter store, then you store them using an encrypted key from KMS so that it's encrypted at rest. And then when a Lambda function starts up, it will talk to SSM parameter store and fetch those parameters at boot time, so that, again, that happens over HTTPS, so it's encrypted in flight as well. And with a simple cache client, you can then, config client, you can then cache those config values and only refresh them periodically. And a lot of things that me and Scott has talked about today, I've been putting together into a video course with Manning, so go check it out afterwards. With that, I think we're just over time. The slides are available online already. So yeah, thank you guys very much for staying around.